So now that we've reviewed gravity, let's look at a particular case. Let's look at the force of gravity between you and the planet that you're standing on. So I'm on the Earth right now. The force of gravity, the attraction between my mass and the mass of planet Earth, is what we call my weight. Okay? So we're talking about how much me and the Earth are pulling on each other. So if I change my mass, if I go on a diet and lose mass, then the force of attraction between me and the Earth will be less, and I will weigh less. Now, if I change the Earth somehow, let's, for example, the Earth went on a diet and the Earth changed mass, and my mass stayed the same, then the force of gravity between me and the Earth would also change. I would weigh less. It would not fit in my jeans any better, but I would weigh less if the Earth had less mass, because there would be less of a force of gravity between me and the Earth. All right? That, I think, is the easier of the two. If you change the mass of one of the two bodies, the force of gravity changes. If you go to a planet with a smaller mass, even if your mass stays the same, you will weigh less because there's less of a force of gravity between you and that planet. So when you go to the moon, you weigh less because the moon weighs less than the Earth. Your jeans don't fit any better. Your mass has not changed. If you go to Jupiter, you got a problem, because Jupiter is a heavier, more massive planet than the Earth. So Jupiter has more mass. And if your mass stays the same, you don't go on a diet. Jupiter, however, has really pigged out, and it's a very heavy planet. So as compared to the Earth, you weigh more on Jupiter because you have a highly massive planet and you have a stronger attraction of gravity. It's like the example I had of the large book and the small book. Okay? When you have two smaller books, there's less of a force of gravity. When you have a huge book and a little book, there's more of a force of gravity. So that's how mass changes your weight. What about the size of the planet? Okay, here imagine I have here a moon. I know it's a ball of yarn, but it's round. It's the only thing I had here. Okay, so this is a relatively small body. It's a small planet. Okay, so here is my friend the dinosaur. Hey, you got what you got to work with here. So if I put this dinosaur on this moon, if I want to know the weight of this dinosaur, I have to know the gravitational pull between the dinosaur and the moon. So I need to know how much each one has for mass, and I have to know the distance between the two of them. And the distance between the two of them is the distance between their centers. So you'll notice that, again, this is a fairly small moon, so the distance between the center of the dinosaur and the center of this ball of yarn is very small. So there's going to be a relatively small distance between them so that the gravity should be greater, so that they should weigh more. Now, that's only taking into account the distance between the two. That's not taking into account the mass. Remember, the mass is something else. What if I take this dinosaur and now put it on this big thing? Okay? Big planet. Big. Again, we're not talking about mass. We're talking about radius, about distance. Now the dinosaur is a very large distance away from the center of this object. Because the dinosaur is very far from the center of this object, remember how the force of gravity goes down the farther apart the two objects are. So the distance between the center of the dinosaur and the center of this planet are greater than the distance between the center of the dinosaur and the center when it was standing on this moon. And because the distance is greater, the force of gravity is less, so you would weigh less. And again, that's only taking into account the distance. Mass, again, I'm not saying let's assume that the mass of this ball of yarn is the same as the mass of this ball. If the mass of this ball of yarn is the same as the mass of this ball here, the dinosaur weighs more on the ball of yarn because he's closer to the center. The dinosaur weighs less on this ball because the distance between him and the center of the ball is much greater than the distance between the dinosaur and the center of this ball of yarn.